Hi everyone. Today we're going to use side side angle, hypotenuse leg, angle side, and side to prove two triangles are congruent. So the first proof we have, we are given that TM is congruent to PR. So we can say that TM is congruent to PR. And again, I just really want to remind you that anytime you're given any information in the given, draw it on your proof, draw it on your picture, because it's going to help you. You also know that TM is parallel to RP. So two things. Number one, in the given, we're going to write TM is congruent to PR, and that's given. We also know that TM is parallel to RP, and that's also given. But you need to ask yourself, why are they giving you that these two lines are parallel? So with these two lines being parallel, they give us alternate interior angles congruent, meaning I know now that M is congruent to R. So I'm going to say that, I'm going to say angle M is congruent to angle R. I also know, and I'm going to put one slash here, I also know, because these lines are parallel, that T is congruent to P. So I can say also angle T is congruent to angle P. And that's because alternate interior angles are congruent. Next, so actually, I have enough information to prove that these two triangles are congruent by angle side angle. And so I could do that. I can say triangle TEM is congruent to, let's see here, is congruent to PER. And that's angle side angle. And I'm done. But I would say that there is another way to show that these two triangles are congruent to prove that. And that's also to say this angle here is congruent to this angle here by vertical angles. I could do that. If I had done that, I would say angle TEM is congruent to angle PER. And that would be because vertical angles are congruent, the vertical angle theorem. If I went that route, then I could also say, of course, that TEM is congruent to triangle PER, but I wouldn't say angle side angle. I would say angle side. So the big picture here is that there's multiple ways of proving two triangles congruent, and that you just have to find the way that works for you. So just a reminder that there are 5 ways. So there are 5 ways to prove two triangles are congruent, and that they are side, proving that 3 sides in one triangle are congruent to 3 sides in the other triangle. Side angle side, a side and angle and a side congruent to a side and angle and a side. Angle side angle, remember the side is in between the 2 angles. Angle side, hypotenuse leg. And once my 2 triangles are congruent, then all the parts are congruent. Once the 2 triangles are congruent, then all of the corresponding parts, and then that's important that you say corresponding, all of the corresponding parts are also congruent. Okay, so starting off with this proof right here, we know that ZW is parallel to YX. We know that ZW is congruent to XY. I think I said YX. Yeah, XY, YX, same thing. So we know that these are parallel and congruent. I'm trying to prove that 2 is congruent to 1. Well, before I can prove that 2 and 1 are congruent, I need to first prove, big picture, is that the two triangles are congruent. Because once the two triangles are congruent, then all of the parts are congruent. So the first thing I'm just going to say is my given. So here's my given. Okay, there's my given. I've said that. Now, why did you think they told me that ZW was parallel to YX? So the reason why they told you that is because you now know that angle 3 is congruent to angle 4. So, and the reason that angle 3 is congruent to angle 4 would be because the alternate interior angles are congruent if you have parallel lines. The next thing you know is that ZX is actually congruent to itself, and that's because of the reflexive property of congruence. So we also know that this value here is congruent to itself. And if you think about it, now I have a side congruent to a side because that one side is in both triangles. An angle congruent to an angle and a side congruent to its side. So I actually, sorry about that. So I actually have the two triangles congruent by side angle side. And once once both of the triangles are congruent, well, then the parts are congruent. I can say any of the parts are congruent. I can say one's congruent to 2. I could say ZY is congruent to WX. I could say any of the parts are congruent, but because this is what I'm trying to prove, that's done. Corresponding parts of congruent triangles are congruent. So definition of a line perpendicular to a plane. So basically what this is trying to say is a line and a plane are perpendicular if and only if they intersect the line at a perpendicular place, meaning in this part right here, this value here, that's going to be perpendicular. So now I know that angle POA, and angle POB are right angles. And you know that once you have right angles, all right angles are congruent. So we have a proof here. And at this point, I actually would just say, stop the video for a few minutes and try to fill in the space. I mean, what you do know is that PO is perpendicular to plane X. If that's perpendicular, that's going to happen right there, okay? You also know that AO is congruent to BO, and that's going to happen right there. You also know that PO is congruent to itself because see how this is in both of the triangles? Now you're trying to prove that PA, which is this side right here, is congruent to this side right here. Well, all you have to do is prove that the two triangles are congruent first in order to say that the sides are congruent. Because once the triangles are congruent, then all of the parts are congruent. So what you would do for this now is, set up your steps. So we just went through what you're supposed to do. Now you need to set up your steps. So I would pause the video and then continue in a few minutes. So, all right, here we go. Now you're back. So with this, I've written everything out. You have given, you know that you do need to say this, that these two sides are perpendicular because perpendicular, the definition of perpendicular lines, definition of a line perpendicular to a plane states that PO is now perpendicular to AO and OB. You then know that they're right angles. Well, you say that the measures are 90 degrees. So once you have two 90-degree angles, you know that all right angles are congruent because they're 90 degrees. And so therefore, you could say definition of congruent angles, substitution would also be okay. PO is congruent to PO, that's reflexive. And then the last part, you have the two triangles congruent. And once the two triangles are congruent, then all of the parts are congruent. Okay. So now we're going to do some more proofs. And again, as I start these, if you want to pause and do them yourself, that would be a great idea and great practice. And then go back through them after I'm done, or after you're done to check your answers. So the first one says that DF bisects. So we have ray DF, and that bisects angle EDC. G, EDG. So let's see here, DF. So here's DF, and that bisects EDEDG. So it bisects this angle here. Well, if a ray bisects an angle, that means it cuts it in half. And so therefore, because of this one statement in the given, just this, I know I haven't written the whole given statement down. Just because of that one statement, I already can say that angle 1 is congruent to angle 2. Because why did they give me that? They gave it to me because the definition of an angle bisector, okay, and that's why 1 is congruent to 2. In addition to that, what else did they give me? They said that DE, so I'm also going to say DE is congruent to DG. So DE, there's DE, is congruent to DG. Well, in order to prove a part of one triangle is congruent to a part of the other triangle, I'm trying to prove that E is congruent to G. I first have to prove that the triangles are congruent. So then I only have a side congruent to a side and an angle congruent to an angle. But if I use this side here congruent to itself, so number 3, I would say DF, line segment DF is congruent to line segment DF. And if that's congruent to itself by the reflexive property of congruence, then if those are congruent, then I can then say that triangle EDF, so EDF is congruent to triangle GDF, and that would be because of side, angle, side. So once my two triangles are congruent, then all of my the parts of my triangles are congruent. So now I can say angle E is congruent to angle G. And that's, again, CPCTC. And that's corresponding parts of congruent triangles are congruent. So we have another proof. You're given that angle 1 is congruent to angle 2. So we're given that this is congruent to this. You're also given that the measure of angle 3 is congruent to the measure of angle 4. So I'm trying to prove that M is the midpoint, which that would be the midpoint if this segment was congruent to this segment. Well, those segments are going to be congruent if I can prove that the triangles are congruent. So in order to prove that the triangles are congruent, I need one additional piece of information, and that's LM is congruent to itself. Then I know the two triangles are congruent. So let's say what we're trying to say. The measure of angle 1 is congruent to the measure of angle 2. The measure of angle 2. We know that the measure of angle 3 is congruent to the measure of angle 4. And that's given. You know that LM, line segment LM, is congruent to line segment LM because that one triangle is in both. That one side is in both triangles. So that's reflexive property of congruence. And you also know that because you have an angle congruent to an angle, a side congruent to itself, and an angle congruent to an angle, I can say that the two triangles are congruent. I can say LJM is congruent to triangle LKM by angle, side, angle. And therefore, the two triangles are congruent, the parts are congruent. So now I can say that JM, line segment JM, is congruent to line segment MK, and that's the parts congruent by CPCTC. Now, I still haven't proven that M is the midpoint of JK, but if I know that this is now equal to this, therefore M must be the midpoint. And so number 5 would say M is the midpoint. And the reason of JK, and the reason for that would be the converse, because remember, the definition of the midpoint says if M is the midpoint, then JM is equal to MK. So the converse would say if JM is equal to MK, then M is the midpoint. So that's the converse of the definition of a midpoint. Okay. Another proof, we have AB is congruent to DC. So we have this congruent to this. We have AD congruent to BC. And, well, we also know BD is congruent to itself. And now the two triangles are congruent by side, side, side. That being said, I'm trying to prove that the two lines are parallel. Well, once I'm trying to prove this line is parallel to that. Well, once I know that the two triangles are congruent, then the parts are congruent, meaning angle 1 will be congruent to angle 3. You need to be careful, though, that if this line is parallel to this line, then only 1 is congruent to angle 3. 2 is not congruent to angle 4. They are congruent, but you can't say that AD is parallel to BC unless you say 2 is congruent to 4. So you got to be careful with that. Okay, so number 1, we would say AB, the given, is congruent to DC. You know that AD is congruent to BC. All right, and that's just given. Number 2, we're going to say that BD is congruent to itself. BD is congruent to BD, and that's reflexive property. Anything congruent to itself is reflexive property of congruence. All right, so now I can say the two triangles are congruent. So let me put number 3 there. So for number 3, I can say that triangle ABD is congruent to triangle CDB, and that's because of side, side, side. Now, once the two triangles are congruent, all the parts are congruent. So now I can say angle 1 is congruent to angle 4. No, that's not what I want to say. I want to say angle 1 is, angle 1 is here, congruent to angle 3. And the reason for that is alternate interior angle theorem. Alternate interior angle theorem, which basically states that my alternate interior angles are congruent. And lastly, if alternate interior angles are congruent, then the lines are parallel. Hold on a second. This right here, let me move this down. These two parts are congruent by CPCTC. So CPCTC. And therefore, the alternate interior angle theorem converse says that if my alternate interior angles are congruent, then my lines are parallel. So I have AB parallel to DC. Cool. Okay. So we have BC congruent to DC, and we have 3 congruent to 4. Well, I'm trying to prove that AC bisects BAD. Well, if I'm trying to prove that it bisects that, I definitely need it to say that 1 is equal to 2. I can say 1 is equal to 2 if I can prove this triangle is congruent to this triangle. So let's do that. So the first thing we know is that BC is congruent to DC, and we know angle 3 is congruent to angle 4, and that's just given. We also know that AC, that line in between the two triangles, is congruent to itself, AC, and that's the reflexive property of congruence. And so I know this is equal to itself. Well, that makes my two triangles congruent. And my two triangles, which are triangle, let's go with ABC. And there's multiple ways of saying that the two triangles are congruent. Remember, there were 5 or 6 altogether from the beginning. So ABC, and we're going to say that's congruent to ADC. Number 3, and that's because of side, angle, side. And once my two triangles are congruent, then all of my parts are congruent. And so I can say angle 1 is congruent to angle 2. by CPCTC. And lastly, once I know that my parts are congruent and I know that angle 1 is congruent to angle 2, therefore, ray AC must bisect angle BAD, converse of the definition of an angle bisector. Because remember, the definition of an angle bisector says if ray bisects the angle, it cuts it into two equal parts. So the converse would say, if my angle is cut into two equal parts or two congruent parts, then that line in between, which is a ray, must bisect it. And that's the converse. So we have, another proof. Let's see here. Here we go. We have this proof that says J is congruent to K, and we know that 1 is congruent to 2. Well, we also know that LM is congruent to itself. So that would prove this triangle congruent to this triangle. Well, if that's the case, if my two triangles are congruent, then I can say that this line here is congruent to this line here. And if those two lines are congruent, if LK is congruent to LJ, then I know my triangle is isosceles. Okay, we haven't covered the isosceles triangle theorem yet. So therefore, we really don't know that if the two sides are congruent, then their base angles are congruent. That's the next day. So we will be doing that next. But for right now, we are going to say that the measure of angle J is equal. If you use the M for measure, you need to say equal. The measure of angle K, and that's given. You've got also given that the measure of angle 1 is equal to the measure of angle 2. So we said that. Number 2, we're going to say that LM is congruent to LM, and that's going to be by the reflexive property of congruence. And now I can say that my two triangles are congruent. LJM is congruent to LJM is congruent to LKM, so LKM, and that would be because it looks like it's angle, angle, side, so angle, angle, side, and therefore now, what are we trying to prove? That it's isosceles, so we could then say LJ, line segment LJ is congruent to line segment LK, and that would be CPTCT. So corresponding parts of congruent triangles are congruent. And lastly, number 5 would be that triangle JKL is isosceles because, number 5, definition of isosceles triangles. So that's it. I hope that helps, and I'll see you next time. Thank you.